Okay, so today we're going to work with linear regression with this class activity that most of you completed called graduating classes. Okay, the table shows the number of seniors who graduated from a small college, and not all of the numbers are shown, but it starts at 1950 and it goes all the way to 2000. And then it wants us to make a scatter plot and describe the trends you see in the data. Okay, the first thing I'm going to do is I'm going to put these. This is my L1. It's my independent variable. This is L2. And so what I've done is I've gone in here in L1, and if you'll notice, my number starts with 0. There's the 203, 211, 288. Those numbers, those 19 numbers are there. But this is 0, then 3, then 7. I want you to look. 0, then 3, then 7, then 10, then 12. What I've done is 1950 is my initial value. We've talked about the initial value. That's going to make this my y-intercept, the 203. And so I've listed all the numbers in there, and we're going to create this scatter plot, and we're going to look at the trends of it. So the first thing I'm going to do is let's go ahead and draw our lines here. Let's see, do I have something I can draw lines with? Let's try this. I'm going to draw my vertical line and then my horizontal line, and I'm going to name this years. I'm going to go since 1950. And then this is number graduated. Then I can go, let's see, it's going from 50 to 2000, so that's 50 years. So 10, 20, 30, 40, 50. And then class size, I'm going to put my little wavy line here. I'm going to go 200. How high does it go? The maximum is 527. So we'll go 200, 300, 400, 500, 600. And I'm just going to label those. Okay. So now let's have the scatter plot made. So second y equals. Turn this on. This is my scatter plot. Okay, and instead of residual here, I need that to be L2 because I put the numbers in L1. This was L1, this was L2. And I'm going to use the square dot. You can decide if you want the square or the plus or just the simple dot. I would always use one of these two because it's always the easier seen. Okay, now that we have that, now I also want to look at maybe the line of best fit for that. So here we go. I'm just going to first go zoom 9. Uh-oh. I've got a mistake. Stat, edit, up. What did I do wrong? Second y equals L1, L2. They have the same amount. And they both have 19. Second y equals, enter. What am I doing wrong? Oh, something else has to be on. There we go. There we go. We do have other things here. Let's clear that one. Let's clear that one. And let's go up here and turn plot 2 off. Plot 2 was on. I don't want it on. Now it'll work. See, sometimes that happens. You say, okay, did I clear my calculator to begin with? You may or may not have. So zoom 9. Oh, there it is. Ooh, that's ugly. Does that look linear to you? Okay, I don't think so. So I'm going to go ahead and let's see what a line of best fit would look like. So stat. Sorry, that's not a great picture on there, is it? It's kind of shaded. I'm trying to find the best place for it. Maybe this will work. Stat, calc. I'm going to go 8 because we're going a plus bx. Whoops, so second 1, second 2, and we're going to store it. Remember, to store a regression, we go vars, go over to yvars, it's a function, and then we pick where we want to store it. Now, real quick, mode, this is the old calculator, so in the new version, my stat diagnostics is turned on, so make sure that your stat diagnostics is turned on, because remember, we not only want our regression equation, but we want the correlation coefficient and the coefficient of determination. Okay, so let's quit that screen. Second mode clears that. So go back to stat, calc 8. We've got everything there. I need to go back vars, yvars, enter, enter, enter. I'm storing y1, and there's my equation. Okay, so I get A equals 323, which is not even close to 203, but this is all a line of prediction. That should raise red flags to me. My B is 2.9. I'm going to make that simple. R squared is 0.256. This is ugly. And R is 0.506. Yeah, that's a almost weak correlation there. It's almost a weak correlation, and it should be obvious to us. Again, when we look at this graph, and there's that line of best fit, it doesn't even come close to my points. Okay, this isn't linear. We should know that. Oops, sorry again. There we go. That's not linear. That's not linear, but it says to sketch it, make a scatter plot. So let's make the scatter plot. Let's see, there's 203, and there's my next one. And let's see, we go 1, 2, 3, 4, 5, 6. Oh, here, we can do it this way. Press the button, whoops, that we can trace, and it puts it on the first one, 0, 203. And then the next one is 3, 211. And then 7, 288. And then 10, 319. And 12, 381. And then 15, 446. And then we drop off some, and then we come up, and then we come there, and then we're at 30 years, it's at 476. So we're, whoops, we got one up there. And then we're coming down, and then let's see, at 34, it's 413. At 37, it's 399. 39, it's 362. Okay, so there's our graph. All right, obviously it's not linear, it's cubic. So trends we see, it increased, steady rise until 1976. It started declining, and did so until 1989. Then increased again. Okay, so we talk about the trends. It increased up until 1976, and then it started declining until 1989, and then it increased again. Okay, down and up. So this data does not show the size for 1969. Create an appropriate model, and when you read the word model, that means equation, and use it to estimate the size of that class. Okay, well, if we look, 1969 is right in this big gap right here. It's in this gap. And so my line of best fit that we found, this line of best fit really is not a good guesstimation of what's going on here. So instead of doing that, we're going to do something a little different. What I'm going to do is on my table, it increases until right here, till 1976. And then it starts that downward decline. That's redundant in it. So what I'm going to do is I'm going to go to Stat, and I'm going to go to Edit. And what I did is I put the numbers from L1 and L2 into L3 and L4, but I took off the last 9 numbers. I just went to 1976, which is 26 years from 1950, so that should make sense to you. And there's my number, 527. So now I'm going to go back to second y equals. I'm going to turn this plot off. I'm going to go to plot 2, turn it on. Again, I'm going to do a scatter plot, but I'm going to use second 3 and second 4. And I'm going to go Stat, Calc, 8, second 3, enter, second 4, enter, enter, vars, y vars, enter. This time I'm going to use y2 because it's my second graph. There's this equation. Okay, so here is my appropriate model. Here's my appropriate model. I have grad hat equals, my initial value is 193.9 plus my rate of change is 14.32 times year since 1950. You can just do year if you want. And most of you probably put it in there straight like that. Now, again, look at my R and my R squared. R is 98% now, 0.9776. You're going to round that up, might as well. My R squared is 0.96. So I'm going to write that here. R equals 0.98. R squared equals 0.96. That's nice. Those are great numbers. So let's look at this graph. So let's zoom 9. Oh, I forgot to turn that equation off. There's our line of best fit, though. That looks so much nicer. Let me turn this equation off. Okay, there we go. Look at that. We are statisticians. We can do that. We just drop the last 9 numbers and we get this look. Now for 1969, I can go second table. And 69 from 50 is 19 years. I can go down here to 19 years, and it says about 46.05 students. In other words, I'm going to substitute in 19 right there. And so we're going to have 193.9 plus 14.32 times this, and that equals 466.05. Okay, and remember, explain what years we used and why. We used only those that showed the upward trend during which 1969 occurs. Now, it says, what if we wanted to do the graduating classes through the year 2010? What model would we use? Again, this means equation. So let's look here. 2010 is past this. 2010 is somewhere out here. It's at 60. No, yeah, it'd be 60. So there's 50, 60 right about out here somewhere. Well, do we want to include all of these? I don't think so. Do we want to just include these 9? Again, I don't think so, Tim. I think we just need to use this last part. I think we need to start right here. 362 is where it bottomed out and then started increasing again. So we're just going to use 1, 2, 3, 4, 5, 6. We're just going to use these 6 data. And of course, Stat, Edit. I've already done that. Here I've put these last 6 numbers. I put these last 6 numbers into L5 and L6, and we can do this. So what's this going to look like? What is this going to look like? Well, here we go. So use last 6 data points. And we're still everything starting from 1950. We could make this 0 and go from there, which isn't that bad of an idea. So let's do that. I'm going to make that 0. Enter. Let's see, this is 3. This is 5. This is 7. This is 9. And this is 11. Oh, wow. You're going to make this really, you're going to make this really easy to graph. So this is going to be, use last 6 data points from 1989. All right, so I'm going to go back to y equals. I'm going to turn this off. I'm going to go up to plot 2. Whoops, y'all can't see that. There we go. I turned both of these off. I'm going to turn that one off. I'm going to turn plot 3 on. So, whoops, not alpha. Second y equals. Let's go here to plot 3, which is turned on. L5 is already there. Let's make this 6. I'm going to push that dot. I'm going to stat calc 8. I'm going to push second 5, enter, second 6, enter. I'm going to store this in vars, y vars, enter. I'm going to press L3, or Y3, sorry. And here's our new equation. A is 363. Oops, y'all can't see. Slide that up, Pruitt. Slide that down, Pruitt. A equals 363.8. My B is 8.2. My R squared is 91. That's still pretty good. R is 95. These are both strong correlations now. And then we zoom 9. There's my graph. Now, obviously, you should be able to look at this and see what the major problem is. What makes you cautious about these projections? Well, first, let's find 2010. So we have grad hat equals 363.8 plus 8.2 year since 1989. And we substitute in 2010 would be, this is 11, so it would be 21 years since then, times 8.2. Again, if you use the regular years, this will still work, plus 363.8 in second table, and I want to go 21, and so that's going to be 535.04. You'll see the number there for 21 years since then, or we could do the calculations on our calculator, however. So we would expect, I'm going to go ahead and make this 467 graduates is my prediction, grad hat. So grad hat here, 536 grads. Okay, now what's the problem with this? What makes us cautious? Well, go back to the graph. You only have 6 data points. You only have 6 data points, and this is from 0 to 11, and then we're making a prediction that is something that's 10 years out. Well, if you notice, these are 10-year curves here. This one wasn't. This was a 26-year model, but there's 10 years, there's 10 years, approximately. So we're making predictions well beyond where we probably should. We have a very small sample size. That would be my concern. Okay, there is that one.